Today we're going to look at how to add and subtract rational numbers. And you guys already know how to do this. You covered this in elementary school, but it gets a little more complex when we add in exponents and variables to this. So let's review really quickly, right? So if you have like 1/4 plus 1/3, how do you add 1/4 plus 1/3? You have to have a common denominator. The denominators have to be the same number. So the way to do it, the easiest way to do it, in my opinion, is to basically find the least common multiple of 4 and 3, right, of these two numbers here. So 4 and 3, if you do 4 times 3, that would give you 12. And if you do 3 times 4, that would give you 12. So we're going to make 12 the denominator. But we ask ourselves, right, so like, okay, sorry, I shouldn't put a 1 over 12. I should put over 12 plus over 12. And the question here is, like, what do I need to do to this guy 4 to get to 12? Well, you're going to have to multiply the bottom by 3 to get there, right? And if you multiply the bottom by 3, you don't want to actually change the ratio here. So you want to multiply the top by 3 as well. By doing that, what you've done is you've effectively said, hey, 1/4 is the same thing as 3/12. They look different, but they're actually equivalent, right? They're equal. If you type them both in the calculator, you get 0.25 for both of them, okay? And then on this guy, you need to multiply by 4 to get to 12, so you need to multiply the top by 4 as well. 1 times 4 on the top is 4. And then what you do on this is you add the tops, but you leave the bottom alone. So 12 is your denominator. It stays 12. And then you add 3 and 4, and you get 7, okay? We are literally going to do the exact same thing today, except we're going to do it with variables instead of just numbers, okay? So let's see how it works. I got some different examples queued up for you. So on this one, you have 7x plus 2 over x minus 8 plus 5x. This would be very similar to having a fraction like 1/2 plus 4. And all you need to do is you need to make sure that the 4 also has a denominator of 2. So it's going to get multiplied by the top and the bottom by the same number, okay? In this case, the number, and I say that with air quotes, is the x minus 8. So what we're going to do here is we're going to give this an x minus 8 here, okay? So we're going to multiply by x minus 8. Make sure when you guys do this, you do it in parentheses on the top. So what we have now is we have 7x plus 2 over x minus 8 plus, and now we need to actually FOIL this in here, okay? So we're going to have 5x squared minus 40x over x minus 8. And then what you can do is you can add them together on the top. You leave the x minus 8 on the bottom alone, right? That's kind of like your 12th from the last problem that we just looked at. And then what's on the top? So we have 5x squared. I'm going to write this in standard form here. So 5x squared minus 33x plus 2. Okay. Now, when you do this, you do want to double check and make sure that you can't like factor this at all. Because sometimes what will happen is you can factor the top and it's like, oh, hey, it cancels with the bottom. But I don't think you can factor this. 5x squared minus 33x plus 2. I mean, the only thing you could do would be 1 and 2 here. And I don't think there's any way we can get to 33. Like even if we put a 5 here, 5x and 1x. Yeah. So we would just say this would be our answer here. This is super useful in programming when you're trying to take expressions that look different and just combine them together in one expression and just tell the computer like, hey, use this. Don't like feel like you have to do that. So, all right, let's go to example 2 here. So example number 2 is an example where we have 2 different denominators. So what I'm going to suggest here is that you make the common denominator. So the common denominator. And I'm not going to suggest this in every case, but in most cases I suggest this. The common denominator is going to be the product of these two things. So it's going to be x plus 4 times x, okay? So in doing this, the question here is for this term right here, what do we need to do to the denominator to get it to be x plus 4 times x? Well, the bottom needs an x here. And if you're going to multiply the bottom by x, you need to multiply the top by x as well. On the other fraction, what does this one need? This one needs the x plus 4. Please make sure you put this in parentheses. So we do x plus 4 there on the top and bottom. And now we're going to write it all together. So on the left one, we have x times 1 over x times x plus 4. Do not multiply the bottom. Just leave the bottom alone, okay? And then on the top, you're going to have x plus 4, right? 1 times x plus 4 over x times x plus 4. Don't multiply the bottom. Just leave it alone. The bottom you can leave as x times x plus 4, And then on the top, we're just adding across. So if you have x plus 4, that would be 2x plus 4. You cannot cancel this. You cannot cancel that because there's addition right there. Okay, so we literally just leave it like that. Like we're just happy with that as a simplified version of this. I know it doesn't really feel simplified, but that's how we do that. Okay. If Delta Math wants, I don't think they will, but they might want you to multiply the bottom. I don't really multiply the bottom. I don't play around with that. So don't feel like you have to multiply the bottom. Okay, let's look at another example. Example number 3. This is one where I wouldn't necessarily just multiply this by this. What I would do is I would actually factor the left side if you're able to. So 7, you can actually factor this left side here. The right fraction we're going to leave alone. Okay, can't really do anything on the right fraction. But on the left fraction, you can actually take x squared plus 6x plus 8, and you can factor that. So that's going to break down into x. We would want two numbers that multiply to make 8 and then add to make 6. So that would be like 4 and 2. Positive 4 and positive 2. Okay? So now the question here is if we want a common denominator, right? Like what should we make the denominator if we want a common denominator? And what I've done here is I've highlighted the fact that both fractions already have the x plus 2 in them. So we don't really need to multiply by x plus 2 here. If we want a common denominator, then really all we need is to make sure that everybody has this x plus 4 as well. And then we're good. So all we're going to do here is we're just going to tack on this x plus 4 on this fraction over here on the right. So he's good to go. Now we have a common denominator. So this would be 7 minus x times x plus 4 over x plus 4 times x plus 2. You can put this into Delta Math here, but they probably want you to actually multiply that top part there. So I'm guessing they probably want 7 minus x squared. We're going to distribute this minus x here. So minus x squared minus 4x over x plus 4 times x plus 2. We typically like you to rewrite it in standard form here. So we want negative x squared minus 4x plus 7 over x plus 4 times x plus 2. And this would be good. I would double check. Let's double check this real quick. Can we actually factor this guy right here? I don't think we can factor that. I would need two numbers that multiply to make 7 that add to make negative 4. Yeah, that doesn't exist. So, okay, that would be it. That would be your answer for that one. Okay, so once you kind of get the idea on these, they're not too bad. I want to show you a couple other kind of weird examples, and then you guys can go ahead and work on the Delta Math here. So on this one, you might be tempted to think, oh, I better just multiply the yellow by the blue here. Not necessarily, right? Try to factor if you can. So if you factor the left fraction, you can actually factor it. So the left fraction becomes, that's a difference of squares, right? That's x squared. 49 is 7 squared. So this is going to be x plus 7 times x minus 7. Now, this is exactly like the last one, right? So they both have the x minus 7 there. This one on the left has the x plus 7. So we're going to make our common denominator this right here. So what do we need to do? This fraction over here needs to have that same denominator. So we need an x plus 7 here and an x plus 7 here. So what would that be then? This would be 2 over x plus 7 times x minus 7. Let's just do it all on the top here. Let's distribute this. You ready? 7x. By the way, we're distributing a negative 7 here. So this is a negative 7. And then minus 49. So Delta Math will probably want you to simplify this. So we have x plus 7, x minus 7. And then on the top, we're going to have negative 7x minus 47, right? Negative 49 plus 2 would be negative 47, okay? And it should accept that right there. That would be your simplified version. All right, this one's a little weird. These can actually be done very quickly. If you actually do, sorry, got to clear my throat here. If you actually get a common denominator of 9 minus x times x minus 9, that'll work. It's not wrong. But there's actually a quicker way to do this, and that is to realize that 9 minus x is just x minus 9 times negative 1. So what we're going to do here, this is going to seem a little weird. If you see them flip-flopped like this, what you can do is you can multiply the left side here by negative 1 on the top and bottom. When you do that, watch what happens. You get negative 1, And then on the bottom, what do you get if you distribute the -1? You get -9, and then -1 times -x is plus x. So what's -9 plus x? It's really x minus 9, which is the exact same thing as that. So really, this denominator here is just x minus 9. And then on the fraction on the right, you have 5x over x minus 9, and now we have the same denominator. So we can just say, hey, this is 5x minus 1 over x minus 9. Okay, so they might throw some of those at you. So look out for those. Anytime where you have like a plus or a minus 3 and 3 minus a, just multiply this guy by -1, and it'll become a minus 3, right? Okay, cool. So that's another little trick. Moving on, I think this is the last one here. So how about this one? So we have multiple things over here that have no denominator. This one has a denominator of x plus 7. So we're just going to come over here and tack on an x plus 7 denominator. And if we do that, we just got to make sure that we multiply the top by the same thing. So x plus 7. So now this fraction over here on the left becomes, let's FOIL this. So this is going to be 2x squared plus 5x plus 14x plus 35. Okay? And then the one on the right here doesn't change. So our final answer here for this one is going to be 2x squared plus 19x plus 36 over x plus 7. Ooh. You should check. They probably aren't going to factor today, but I always recommend checking. So 2x squared plus 19x plus 36. I'm going to actually type that in just for the sake of time. I just don't want to play around with that one. Factor 2x squared plus 19x minus 36. Sorry, plus 36. Let's see. Can you factor that at all? Looks like you cannot. Okay, so it looks like that's prime. Okay, there you go. And really, I know it's not going to factor into x plus 7 because it would be 36. So you're not going to get a 7 to pop out of that. So we're good. Okay, that's how you add and subtract rational expressions.